recording. Start streaming. Okay, connecting. All right. Let's see. Is Twitch? Yes. Awesome. We're live. Great. Hello, Twitch. For the first time ever. Hey, Jeters. So we're trying streaming on Twitch to see what that's like. And we're going to continue where we were last time. We also had a special request for us to talk about versioning from our metaphor friend. So we're going to do that. But I wanted to dive in a little bit more on the Gemini example because I kind of did a speed run through the code it generated, and I want to actually walk through so we can see where Gemini kind of went wrong. And then we'll switch to versioning for the application binary interfaces, application programming interfaces, contracts, all that stuff for untranslatable metaphor. And for those of you who are new to GTT, which is probably almost everybody on Twitch, we are mostly a technology channel, and we talk about machine programming. And we also talk about life. Oh, we talk about music too. Speaking of music, for you Jeters, I've got this one on repeat. Let me drop it into the chat. Mur, if you're watching, I think you're going to like this. This is Among Thoughts. And yeah, I figured out now that I can just say it, but typing out so there's no confusion on, I think this is the artist. There we go. Now you guys know how to spell it and all that. This is pretty good. It's like 7 minutes long. This is going to be playing on repeat on these guys for this one. Okay, so last time we were looking at, what was it? Yeah, it was, no, it wasn't you. It was the G guy, right? Yeah, this guy. We're looking at this, and what was the one we were, let's go over here. This is our root. Wonder if I can type this. Root. There we go. Excellent. Okay. So we were looking at this control expression, and we didn't look at how Mentor tried to solve this, but we looked at two different solutions from Gemini. And very quickly to recap, there's three major expressions, sub-expressions inside of this single expression, and it's copy-pasted here. So let's take a look at this. I'm just going to add some white space to try to make this a little bit easier to visually process. I'm going to actually move this a little bit over the chat just for a second. And oftentimes this is what I'll do to try to understand like the actual logical breakdown of these things, just to make it easier to see. So here, now what I can see is there's essentially three core sub-expressions inside of this single control expression. And because these are all ORed together with this guy, all we need is one of these to be true, and the whole thing will be true. And that's super important. And what I'm shooting for in this example is I'm going to see if I can find a single case where we can get one of them to be true and the other to be false, which I guess in this case is probably since it's binary, there's really only those two differences. So this is the original expression. And then this is, did I miss a paren here? I didn't. Okay, cool. Yeah, so, oh, I see. Oh, I get it. Okay. Sorry, I was trying to figure out what's going on here. And I think maybe to double check, I think maybe in JavaScript or Python, maybe you don't need parens on the outer portion of the if clause, but you do for C and C++. And so the reason why I was pausing there is I was thinking this code wouldn't even compile, because in C++ it wouldn't, because you would minimally need these extra parens, because these parens here, what would happen? I didn't even recognize this failure the first time. Yeah, they are dark and full of terrors. I definitely a lot more flexibility, but so one of the things I was mentioning, I think actually at the board meeting yesterday, is this notion that many of the code assistants really are principally focusing on languages like Python and JavaScript, scripted languages. And I think that this is potentially an interesting example. Is the example we gave it included all the right parens. And so it is using parens, but I think that it's assuming a parenless if statement. And that's why it included parens here and parens here. But in C++, what would happen is it would parse this out, and then it'd be like, this is the closed paren. This if expression is done. And then this would be a compiler error. It'd be like, or can't just float in outer space, guys. And so to get this code to even compile so we could see what's wrong with it, we'd minimally have to do that. Okay, so now we fixed that first piece. This is probably not giving us like, this is maybe the first point where we might pause and question our source of truth. This being, source of truth being whether or not this code is going to actually work. Because if you're not even generating code that is compilable, then, or for the language that we're targeting, then yeah, that might not be like the best starting point. Okay, so that aside, now let's dig into this a little bit more and try to understand how this can go wrong. I want to also say that when I first saw this, it just seemed like if this is the original expression, this is a pretty notable reduction. And to be honest, these types of things can happen. This isn't like, I mean, you have things like De Morgan's law and others where you can do these reductions. And there is some interesting overlap here. Like, you'll notice that the first three params in this first sub-expression are essentially the same, with this one being knotted. So the first two Booleans are identical in both sub-expressions, and then the third is different. And I think this is maybe the first mistake it makes, because it's trying to explain, I think, over here that, look, it says this: notice the conditions 1 and 2 both require these to be true. If these two are true, the state of identity being watched doesn't actually affect whether the overall condition is true in these two scenarios. That would be correct if this last parameter was not part of the first expression. So if this piece was gone, right, then yes, identity being watched could be true or false. It wouldn't matter, as long as these two are true, because it's basically acceptable in both of these. The difference, though, is that when this is true, this must be true as well for this first condition to pass. And then when this is false, well, it doesn't say. So in this case, when it's false, it can, I guess, be any value. But that's not the case when it's true. And so therefore, this elimination is already logically questionable, right? Like, we haven't looked at how it could impact these other things, but that first reduction feels, at least this argument is not complete, or at least I'm not fully compelled. So, and then it goes on to say, similarly, condition 3, identity being watched to be true and identity has value to be true, regardless of the state of root being watched. Sorry, my phone's just blowing up for some reason. So again, this is true-ish, because it's talking about how these two guys being true are related to these two guys being true. And now this guy can be true or false in either of them. But again, it suffers a similar consequence of it is not considering that root has value, needs to have a specific value in this case. So the whole logical breakdown is feeling a little bit dubious. It's like a little loosey-goosey right out of the gate. And so this hopefully should give us some clue that we might want to do deeper analysis. Again, what's somewhat tricky about this is when you start with simple examples, it actually works. So when I was first looking at it, it was passing some of my early tests. I'm going to just move this a little bit. I need to learn to stay on the mic, but yeah, okay. So now let's walk through an actual case I came up with so we can see that it kind of has these issues. Okay. So here's their expression, and then here's the original expression. And I came up with this case. Now, I worked through a number of other cases, but I'll just show this one. I came up with this case where root being watched is equal to true, root has value is false, and then both identity being watched and identity has value are true. All right. Then what I did is I took the first expression and basically broke them down into the three sub-expressions and then calculated what they would be with all of these things set up. Now, before I dig into this, keep in mind that these are being ORed together. So all you need for this total expression to be true is you just need one of them to be true. That's all you need. So in order for this to be false, in other words, you have to have everything be false. And given that I was trying to show that things would be slightly different, it seemed as though trying to find a case where one of them would be false and then the other would be true would be a good starting point, rather than the opposite, like trying to find a case where it's true and then hoping the other would be false, if that makes sense. So that's what I went after. And in this case, condition 1, it seems as though I was thinking that this is false. Let's see if that actually makes sense. Okay, so root being watched is true. Root has value is false. I can stop now because these are all ANDed. And when you have full ANDed clauses, any one that's false, it'll make it entirely false. So this one's false already with the second one. Okay, now we go to the next sub-expression. Root being watched, that's true again. Root has value, this is false. I can stop. This is going to be false because I know now both the first two sub-expressions will be false. Now we'll go to the third one. Condition 3, root not being watched. Root being watched is equal to true, and then it's set to false. So that's false. And now we're done. We have all three false. Okay. Now we go to this expression. All right. Same truth table, same true Boolean state for the program. And we analyze the first condition, right? These two guys. Root being watched is true. Root has value is false. So this is false. Then identity being watched is true. Identity has value is true. So this is true. Then when you OR them together, this is false. This second one is true. The outcome of this conditional, it will be true. The outcome of this conditional will be false. These two expressions are not equivalent. So yes, Google, I would like you to elaborate to help me understand how your code is right. Okay. We don't pick on people here, even if they're $3 trillion companies. We're going to keep it low key and not do too much of a little dance. But I wanted to just take a moment and walk us through this so we could see how this actually breaks down, what the actual results are, and the state that the Boolean state for the program that I found that would cause these two to be different. And as we were talking about before, probably something that makes this even a little bit more challenging is the fact that first, it's fairly convincing in the argument it puts together, which, you know, I really wish, this is like a responsible AI thing, is to provide some amount of confidence score. Like use an adaptive Bayesian network or something that is going to give you a distribution of the data that you've looked at. And so you can come in saying, I have a 74% belief that I'm right here. So people can at least have an intuition on whether we should believe you or not. And I think this can be done. There's a variety of ways to do this. And so just having that little number, it's 55% sure this is right. Then this system can like strong claim stuff all at once. I think then that's totally fine. Strong claim away. But if you don't first add that piece, the strong claims make it super compelling to believe in this. And then, as we discussed last time, one of the things that makes this potentially even trickier is this works for many of the cases, probably most of the cases that someone would test. And so if you were rewriting this code and someone's like, well, I'll just copy paste this, and then you have not fully exhaustive tests, you might be convinced that this code is actually a reduction of the original. and you commit it and people aren't looking very closely, and then a year from now someone figures out a way to essentially hack your system because they can get this thing to go awry with exactly the right state. Not super great. So I guess the takeaway is Mentor wins. Oh, and by the way, for Mentor, I did look at all 4 of its solutions, and most of them kept it pretty, like, they didn't actually try to reduce the logic as much as they tried to move the logic out of the conditional. But there was one in here that it did a logic reduction, and I looked at it and it made me a little nervous. I think it's this one. Okay, maybe it's not this one. No, this looks like... this. No, maybe it's not this one. Okay. Maybe I'm clueless. I thought that it did a reduction on one of these solutions, but it worked. It was a reduction that's valid, and it could be the reduction that I saw Gemini do on the second example, because this reduction, yeah, yeah, I don't think that that's a valid character in C++. I think, what is this? Is this a... this is another programming language thing. Is this a Python thing? This colon thing makes me... is that a Python thing? I feel like that's a Go thing as well. Too many programming languages. Anyway, so this reduction, though, which is actually shorter than the original, right? I think that this one, it looked like it worked. So that's cool. I'm happy about that. But just maybe be real careful, especially if you're doing production level code with some of these guys. It seems like the fidelity is... hopefully it will get to the level where it'll be far more trustworthy. I think once we get the confidence score, things will go much better, because unless we're doing formal verification through some sort of constraint solver, it's hard for me to imagine that you would ever have 100% guarantee that what you're proposing is correct. I don't... oh, it says Python here. Yeah, if I could learn how to read. So this is Python code. Yeah, I guess maybe it couldn't tell. It is interesting how it replaced the ands with the word and and or. Although I think that is actually valid. Anyway, so enough about that. Now we've walked through this, so any of you that thought maybe I was just making stuff up, hopefully you're at least compelled now that it did actually come up with something that didn't quite work. Okay. So now for untranslatable metaphors request on versioning. Before we get into the various ways to do versioning for these interfaces, I wanted to first quickly go over some of the intuition on why you might want to do versioning. And I found this site, which I felt like I'm just trying to reduce the size so it's not blinding me here. So I found this site, postman.com API platform. And they talk about some really cool stuff. And they talk about API lifecycles and all this fun thing. And then they get into, API first stuff, it's pretty cool, I think, just in general. So if you're interested in this kind of thing, I just stumbled across them tonight, but it seems like some of the things that they're saying here made a lot of sense to me, at least at a skim. Okay, so on this website, we talk a little bit about how we have APIs, and they talk about the the different ways to do versioning and so on and so forth. I want to mention before we get into the versioning that if you have systems that like are fully in your control and the consumer code is essentially never escaping your field of view, like you're the only code that is using the code, you might not need versioning. The only time that I really am stopped in my tracks when I'm thinking about, okay, I'm building APIs and these need to be versioned. The only time I really think this way in sort of absolute terms is if I think that this API is going to be public or this API needs to be perfect. If those two thoughts cross my mind, this API is going to be public, this API needs to be perfect. This is usually a signal to me that I may want to version the API. And again, as we discussed in that last episode, one of the most important things to do with an API that is going to require versioning is to do versioning from version 1. If you don't add versioning in version 1, it can be a doozy. And I think this is the part that people get wrong quite a bit is they know the API is important or they know it's going to be public, but they've never really had to build an API that needs to be versioned before because truthfully, most APIs don't. Most ABIs don't, right? You're just like, you have the function call or the method call, and then as it changes, as it mutates, you just kind of update all the other code that is calling it, right? And that goes back to the original point I was making, which is if the code that calls into your interface is wholly controlled by you, you may not need versioning for your APIs. Or it's probably less severe to have, or less critical to have the versioning in things that are public facing or that you do feel that, I don't know, I need to get this perfectly right. And again, the reason for that is if you get it wrong, you're going to have to change code, of course, if anyone calls into this. But if all that code is in your control, like no big deal. Okay, so now there's a number of ways to do versioning for APIs. Let me actually write down a few of these. And the way that you version APIs, ABIs, interfaces, all this stuff, it is predicated in some capacity by the programming language. I'm going to talk principally about how it's done in like C, C++, but as you use different programming languages, they have different linguistic support for different features, and the programming language that you work in may not have the same support. I can almost guarantee you it won't have the second type of support that I'm going to talk about, but there should be something. And worst case, if it doesn't support the what is it? The Variadic approaches, either through Variadic functions or Variadic templates, you can use an Opaque structure. and the opaque structure can have the versioning built into it. So let me list out some ways that you can do this. This isn't exhaustive. This is more just to show how you could pull this off. So opaque structure, or like fully clear structure. Opaque sometimes is important for hacky things, tricky things that you don't want the general public to know about, but there's stuff in there that in certain corner cases people can access if they have the right kind of need, but most people don't know it's there. That's kind of the idea. What is this? Best viewers on stream. Okay, cool, man. So that's the first way, and we'll quickly look at that. Like an example of that is if you have something like struct fun API, and it has a whole bunch of stuff in it, and inside of this first one you have the version. So the version is inside of this, and then based on what the version number tells you, you'll have specific members inside of that struct that will allow you to do different things. And then you'll cast it to a certain size, and you'll know exactly where things are laid out, because this information will either be given to you or it'll be a clear structure. So if it's an opaque structure, then whoever is delivering it to you will tell you what the layout is. So it'll be like, it'll be something like an int version, and then it'll be like, this is a char pointer for second param. This one is some struct thing of size 1024, and so on and so forth. And then you essentially partition your way through this. And again, what's really important here is that the version comes first, and the version always has a fixed size. So then you can always parse out the version, and then the rest of the structure that is related to this function call can be pulled out into whatever local memory that you may or may not have to then store this and use this data however you want. So let me just add one more point here. So this is like void some fun, and then in this case it would be this fun API thing, versioned fun API, something like that. Yeah, and then you would know that the first, in this case, let's say 4 bytes is going to be the version. You pull that off, and then once you read that version, then that tells you what the rest of the structure will be. So hopefully that makes some degree of sense. Now, the next way to do this is using a Variadic function. And this is something like void some fun ... like this. Okay, so you have something that looks like this. Now, as I was mentioning before, with versioning, you generally want to have the versioning come first, because you don't necessarily know. This will work. This ... will work and support a number of parameters that you can then determine at runtime, but that will basically be fixed unless you have a version that's associated to it that will tell you that the number of parameters or the actual parameters themselves are changing. So while this means variable parameter list, without a version associated to it, it's basically you don't know. So instead, you can do something like, I believe this is valid. Let's take a look. If not, then oh yeah, it is. Okay. So this is my preferred way of doing this, is you have some fun, and the first parameter is the version, and then you read the version, and the version then informs you about all the different parameters that you'll then need to read, and all the things about them, like their size. And then as you move to a different version, then you have different behavior. And then, so oftentimes what happens is inside of this function, you'll have something like this, where you have a switch on the version, and you'll have like case 1, you do this is version 1, and then case 2, this is version 2, and so on and so forth, right? So hopefully that makes sense. And that's how you do different behaviors, and the version changes the parameters. So then you know that if they're using version 1 with certain parameters, then your implementation, right? Because this is the client code is calling into this. You're the one as the server side. Oh, I guess maybe I jumped past that. When we talk about this, we usually are talking about the producer and consumer, or the server and the client. Okay, so the producer is the thing that's basically, I'm going to give you this data and you're going to do stuff with it. You're going to consume all this. And so the way I generally view this is that the client code is the consumer and the producer code is the server. So the client code is going to call into me and say, I need some information for this, and you're going to return things to them. But the things that you process and the way that you process it is controlled by the version that they're calling into that server code. So, or that producer is that they're saying, I'm calling into version 1, and here's the data I have, and then you go through here and do all the fun stuff and then send it back. And so then they call again, or a different client that needs a different version, and you support multiple versions. They then access version 2 or version 12. And what's nice about this is this allows you to evolve the API and take advantage of different technological evolutions, ecosystem evolutions, all of this stuff that could make your core API better, yet you don't break the old systems. You don't break the old APIs, at least unless you want to. And you can if you want to. In fact, they'll often talk about, I think in this article, they talk about how, so here's the section on API versioning, and they explain, I'll probably drop this link into the summary. But they talk about how you can use versioning to support these multiple versions of the API, and it won't have breaking changes as you evolve. This is like one of the key reasons why you do this, is you support the legacy stuff, but you allow the system to kind of move forward. However, there could be a point where you start to deprecate some of the old versions. Now, this is, the guidance here is super non-trivial on when to do this, when not to do this. It's very complicated. And generally what I try to do is I strive toward not creating interfaces that are going to be public and need to be perfect. I strive to not deprecate old versions unless it's absolutely mandatory, like there's a security vulnerability there's some buffer overflow. There's like massive performance issue. There's something that's like critically wrong with that old version. But if that, short of that, if it's just I don't like it, I probably will not do this. And so they're arguing here, like in step 5, that once this new version is stable, then I think you can start to they say, at this point, it's important to offer support to users who have continued to use the old version as they may need help transitioning to the new version. Yeah, I mean, like, if you made it and then you deprecate it, I think one of the fastest ways that you can upset people that are using your system is to have breaking changes in their code. And I want to be honest, there are a lot of big tech companies that do this type of thing with kind of like zero regard for the end developers. And because I said I'm not going to try to pick on any people in particular, I will say that, or sorry, I won't say the specific names of some of these megacorps, but some of them are megacorps. And in some cases, I get it, right? I absolutely understand that there's some really good reasons that they needed to break it because it wasn't going to work with the new system at all, or it was seriously limiting the forward progress of technology. All of these things are great reasons to do this. But it's still gonna create hardship on your user. So just maybe keep that in mind. Is, if you're writing an operating system and there's an old API where it's a security vulnerability and it doesn't work with the new version, I mean, sure, then that you do what you got to do. But this is like, in my mind, a last resort that I think Intel had not deprecated old instructions from their instruction set architecture for x86 for like decades. And I think that's part of the reason why x86 was for a very long time used by many programs, is many pieces of software, is that they didn't have these breaking changes. They didn't require binaries to be rebuilt or all this stuff. And that made a lot of people's lives, I think, easier. So I would, I think that they're right here about choosing the versioning strategy. You want to figure this out. You also want to, figure out if you need a new version. Sure. The first piece actually is, do you actually need versioning for the API? In many cases, I would argue that you probably don't, but except for those two. If you think that the interface needs to be perfect, you think the interface is going to be publicly consumed by code that's out of your control, like you're creating a library, then those are really good targets. Okay. And then there's some other steps. And admittedly, I do think that deprecation can be useful. Like if the API has been updated and it's been, I don't know, 10 years or something like that, maybe that's going to be okay. But planning on a deprecation of an API after you put the new one in place for like just a really short period of time, this is pretty far out. We'll just leave it at that. Now, to go back into the Variadic functions and the Variadic templates is the other one. The quick overview of that is an example of a Variadic function. Looks like this, and this is the Variadic parameter, as I think that's what this is known as. okay. Why can we can read this offline to figure this out. There's a few different terms that it has in different kind of settings. But we're specifically looking at the C and C++ view. So this is our guy that allows us to take a variable number of parameters. Again, this is just one way. You can also have it with these structures that are going to change, and then you sort of bind to this first parameter being a version. And then this way you can add any number of parameters in here that you want. In this particular case, it's using this first parameter as count, which is basically saying, here's how many parameters I'm going to have. And then you use that to inform the things that it pulls off, right? So it says, okay, so I'm going to start getting those variables, and then I'm going to go from 0 to less than count, and then I'm just going to start pulling them off. In this case, I think they're assuming they're all integers, and they're creating a sum. After they get done processing all of this, they end this variadic processing and then do their stuff. It's pretty straightforward, I think. If you haven't used this type of thing before, it's, I think, pretty fun to play around with. Just be careful, because if you have a misbinding, or you have something sent in that is a mismatch, so this says there's 10 parameters and this actually has 7, then things can go wrong in a really fast way. So just be forewarned that this is one of those things where it's like void pointer. So it's very dangerous, super powerful, but yeah, just be careful. And then the third way that they're actually, I think in here they argue that in C++ they want you to use these variadic templates. And what's kind of interesting is I think that these guys essentially are an example of folding. And the reason why I think that's kind of interesting is our friend Untranslatable Metaphor, one of the things he was talking about was was template folding along with template typeless. And so Untranslatable Metaphor, yeah, here you go. Here's a little bit of your folding stuff. As I was reading this, coincidentally, I noticed that this was designed by Doug Greger and Jaakko Järvi. And I think I know both these guys. I think I've met Doug once or twice, but Jaakko, I think I was Googling him. I think when I was working with the C++ committee and community, I seem to recall hanging out with him a couple of times. I might be getting confused about this, but I thought that was the case because his name looked really familiar to me. So I actually thought it was pretty cool that these guys are the ones that maybe brought this to C++. And it was standardized. And that would kind of make sense because I think I was working with the C++ transactional memory folks starting maybe in 2007 to 2013. Yeah, something like that. So, yeah, good stuff. Great guys, super intelligent, and I'm just pumped that I had no idea that they were the ones that brought this to C++. So it's just kind of cool. So good on them. Woohoo! Okay. So as far as the variadic functions go, this is essentially the layout. And by the way, this I don't know that I've done this, just to be clear. I have done the Variadic functions. I have done this before. I don't know if I've done the Variadic templates, and I want to share that my suspicion is that C++ prefers the Variadic templates because they're type safe, and I suspect they probably are. But I also looked at this, and it looks like this is more complex. It's more challenging in the way that you have to make this work. So what you essentially have, so like they'll say here, there is no simple mechanism to iterate over the values in the Variadic template. So what I think that they're doing here, and I haven't deeply looked into this, but maybe I will after this stream, is this is a version of recursion. This is one embodiment of recursion. And this is the recursive piece, and the terminal element is this piece. It's actually a separate function. So usually recursion has its sentinel or its terminal point inside of the recursive function itself. And it'll be just like, if this, then call again, and then else, like return. In this case, what you see is it just keeps calling this, and then it returns, but it just keeps calling. This one here, you will eventually get down to, if I quickly skim this correctly, it will eventually get down to a single argument. And what it's saying here is that called even when this is 0, but does nothing in that case. So you'll eventually get to a single parameter. And when you get to the single parameter, you're essentially done. You're finished. That's my quick skim understanding. So feel free to correct me if I'm wrong in the comments. But this is my very quick overview. I'm going to keep this. Well, we're going to get done in under an hour. This is pretty great. This is my quick explanation for untranslatable metaphor on how we can do versioning for interfaces. And hopefully this makes sense. This is, by the way, this is not exhaustive, but these are the ways that I have seen them done, or I've done them. And I think that there's some other interesting ways to do this when they're like web interfaces. And I think Microsoft had done quite a bit when they were doing their web services stuff. I'm not sure where that is. And I feel like this is done quite a bit with JSON, that JSON has like versioning in its structures, and it kind of follows like this opaque structure type of thing. So hopefully this gives some intuition on how this is done. And feel free to chime in the comments if you've had different experiences or you have other ways that are really cool to do this. We'd love to hear them, and we can all grow and learn. So with that, thanks everybody. This was awesome, and we at least got one random person on our stream other than me and Taylor that is telling us to go visit some other stream site. So maybe next time we'll get like an actual human being. We'll see. But the truth is, I love it. What's my saying? Small footsteps every day. All right, Jeters. Have a great night. We'll talk soon.